All right, continuing on here in section 1.11, I'm just going to grab some problems out of the book and we'll take a look at them. This formula, it says in the book, comes from nuclear physics. I don't know what any of these letters stand for. It doesn't really matter as far as doing the problem goes. We have 2q equals 2I plus a plus s. We want to solve for I. Again, the thing to notice is I is connected by a multiply and it's connected to things by add. When we're solving equations, we do the add and subtract first. So I'm going to subtract a and subtract s on both sides. 2q minus a minus s is 2I. And then it's connected by a multiply, so I do a divide. Answer is I equals 2q minus a minus s over 2. Now, one thing I want to point out that actually is important, I should have mentioned this earlier. In math and in science, things are case sensitive. So if I start with a big Q here, I have to write big Q all the time. If I start with a big Q and you start writing little q, that's a different letter in math. And you'll see that happen in formulas. Let me see if I can find one here. I don't see one in the book. I'm going to make one up here. T equals, I'm just making up a formula here, 2AT. This can happen in formulas that we can have a capital T, which maybe stands for temperature, and a little t, which maybe stands for time. So it is important that you recognize that math and science is case sensitive, and you can't just change from lowercase and uppercase and it be correct. This one, we're going to solve for a. Okay, well, a here is connected by multiply to two things. So this is a pretty straightforward one. To get the a all by itself, we divide by the two things. So our answer here would be a is big T over 2 little t. Okay, so that was really just an example to talk about math and science are case sensitive. So keep the same case as what you're given in the problem. All right, how about T equals C plus D over V? And in the book, they tell you this is from traffic flow. I would assume T stands for traffic flow. I don't know what CD, V is probably velocity, but I don't know. And we want to solve for C. All right, well, C is kind of trapped inside a set of parentheses here. We don't normally write it, but this big fraction bar, you'll remember, is a set of parentheses. So the first thing we need to do is get rid of that set of parentheses. I think the best way to do that, and it matches with what I've said before, that when we have equations with fractions, we multiply by the denominator to make the fractions go away. So I would write TV is C plus D. And then connected by add, so we do a subtract. C is TV minus D. Okay, let's try a few more here. How about, oh, here's one. V, little v, equals big V times little m plus big M over, I lost where it was in the book here, over little m. And we want to solve for big M. So again, a good example where it is important that you keep track of case. Little v is different than big V. Little m is different than big M. Okay, well, same thing. I sound kind of like a broken record here. I have an equation. My equation has a fraction. The first thing I would do is I would get rid of the fraction. To do that, I multiply by little m. mv, m little v, is big V times little m plus big M. Okay, now this is similar to a problem we did before, this one, that we did twice, where we had to get rid of these parentheses, and we saw that there was two ways to do it. We could either distribute or we could divide. Your choice as to which way you like to do it. Personally, I like to divide, so I'm going to divide by big V. So m little v divided by big V is little m plus big M. And finally, to get the big M all by itself, we subtract the little m. So little m little v over big V minus little m, and notice again that that's completely separate from that fraction. Can't combine them together because they don't have a common denominator, equals big M. Okay, let's pick a couple more. They got a couple here that, they got a couple here that are pretty ugly looking. Let's see, how about n, big N, equals n1t minus n2 times 1 minus t, and we want to solve for n1. And this comes from machine design. And again, I have no idea what any of these letters stand for. And what the truth is, it's not really important. All right, well, this one looks confusing because there's quite a few letters here, and we've got some subtraction, we've got these parentheses. But the thing to think about is we're trying to get n1 by itself, right here. n1 is connected to something by a multiply and connected to something by a subtract. And it doesn't really matter that this is a whole bunch of junk. If it were just n1t minus 8, you would tell me add 8 to both sides. It doesn't matter that there's extra stuff here. It's really just one thing. In other words, I would start by adding n2 times 1 minus t to both sides. Get rid of all that stuff that's being subtracted away from my n1. So n plus n2 times 1 minus t is n1t. And now it looks a lot better. I hope it looks a lot better. Now getting the n1 by itself is straightforward. It's connected by a multiply, so you do divide. So answer, n1 is n plus n2 times 1 minus t, all divided by t. All right, let's try a couple more, and I think we'll be good for today. How about I equals, big I, equals VR2 plus VR1 times 1 minus mu, that's the Greek letter mu, throw some Greek letters in there, that makes it even more fun, divided by R1 times R2. And we want to solve for that Greek letter mu. Why they chose to throw a Greek letter into it, I don't know. Makes it fun. This comes from electronics, so mu might be some sort of angle. We use Greek letters for angles a lot. Maybe, that's a guess. I don't know. All right. Well, there's a lot going on here. First, as we've had in many problems, we have a fraction. And my goal when I see an equation and I see fractions are get rid of the fraction. So I would start by multiplying both sides by R1, R2. Those reduce out. That gets rid of the fraction at least. So I'm going to write I R1, R2 equals VR2 plus VR1 times 1 minus mu. All right, now there's some options. This mu is trapped inside those parentheses, so eventually we got to get rid of those. It's connected to something by a multiply. It's also connected to something by an add. So I think I would get rid of this first. I think I would do this subtract and get rid of this piece. The other good option here would be to distribute. Either one of those would be a good option. I'm going to do the subtraction. I R1 R2 minus VR2 is VR1 times 1 minus mu. All right, now similar to what we've seen a couple times here, I've got to get rid of this parenthesis. To do that, I could distribute or I could divide. I like to do the divide. That's my choice. If you like to distribute, do the distribute. So we're going to have I R1 R2 minus VR2 divided by VR1 is 1 minus mu. All right, we're almost there. Subtract the 1. I R1 R2 minus VR2 over VR1 minus 1 is, watch out for this, really common mistake, it's still minus mu. People will forget that that minus is still connected to the mu. So final answer, to get the mu all by itself, we have to multiply everything by negative 1. So I would write negative IR1 R2 minus VR2 all divided by VR1. And you know, when I write this, it's kind of unclear. Is this minus only with the first thing, or is the minus on the whole fraction? So I'm going to put it in parentheses just to be clear that that minus goes with the whole fraction. And then when I multiply this one by minus 1, I get plus 1. And then there's my mu. All right, so that one's pretty ugly, and I would say that's as bad as it's going to get. I probably would not expect to see something quite that ugly on a quiz or a test. But I think all the other problems that we have done in these two videos, I think would be pretty legitimate questions to see on a quiz or a test. Speaking of quiz, there is a quiz posted on Brightspace for this section 1.11, and it will be due tonight at midnight. Email me if you have any questions.